All right, this video here is for some help in determining whether or not an equation has one solution, infinite solutions, or no solutions. So this is not necessarily a section all by itself in the Algebra 1A class in Edmentum, but in the advanced or solving advanced linear equations part section, I believe it is alluded to in there, and it's also going to be some other parts of Algebra 1A where you're going to need to be able to determine this. So there's three types of solutions, or basically three types of equations. There's equations that when you solve them, and this is probably most equations I would say, when you solve them, you get one solution. So in other words, remember, solving for x or whatever the variable is getting the x by itself. So when you get that variable all by itself, you get a single number like x equals 7 or x equals 13, whatever. That is the solution. So if you get x equals 7, that means there's one solution and it is 7. Meaning that 7 is the only number where if you put it in for x at the beginning or back at the beginning into the original equation, it's the only number that will make that equation true, or it's the only number that will make that equation equal. So I'm going to do three examples here to show how do you know when you have an equation that's one solution, infinite solutions, or no solution. Okay, so this is actually, and there's also going to be some extra practice on just solving like the four-step type advanced equations. So if I look at this one here, this is an example of an equation that will have one solution. So I follow my first step is simplify both sides. Okay, so on this side I have x minus 1, which I can't do, so I go right to the distributive property. 10 times x, that's 10x. 10 times negative 1 is negative 10. Got my equal sign. Okay, look at the right side. 8x minus 2. I cannot do that, right? Because they're not like terms. One has an x on it, the other one doesn't. So I just bring that down. 8x minus 2. Okay. Second step. If there is variables on both sides, if the variable is on both sides, I need to eliminate the smaller one, which it is. In this case, I have a 10x over here, and then on the right-hand side of the equal sign, I have an 8x. So 8x is smaller than 10x, so I'm going to eliminate 8x. This is a positive 8x, so I'm going to subtract 8x, but if I do it on this side, I've got to do it on this side. Okay. This is 0, which is why I did it. 10x minus 8x is 2x. So bring down, right? Bring down what you got left. 2x, then the negative 10, I still have that there, the equal sign, and the negative 2. Okay, so now we're down to our third step, which is isolate the variable term, or get the variable term by itself. 2x is the variable term, so I need to get that by itself. All right, so how do I get rid of the negative 10? I add 10, again, to both sides. Okay. That's 0, which is what I wanted. And then negative 10 plus 2 is positive 8. So I'm going to have to bring over here because I ran out of room. I'm going to move over to the right. I have the 2x left on the left-hand side of the equal sign, my equal sign, and positive 8 left on the right-hand side of the equal sign. Last step, isolate the variable. Get the variable by itself. This is 2 times x. So to get rid of 2 times, we want to divide by 2 on both sides. 2's cancel out. X equals 8 divided by 2 is 4. Okay, so this is one solution. The solution is 4. It only has one answer. 4 is the only number that would be a solution, because it's the only number that if I went back to the very beginning and put that number in for x, it would make this whole equation true. Okay, meaning that if I put 4 in for x, I would get the same number on both sides of the equal sign. Okay, moving on. Now, what about many or infinite solutions? Infinite stands for infinity, or comes from the word infinity, which means goes on forever into the positive or the negative direction, which means that when you solve an equation like this one I'm going to do here, this is an example of an equation that has infinite solutions or many solutions, which means that it doesn't matter what number I put in for x, I could put any number I wanted in for x, positive or negative, and they would all work. They all would be solutions. So that's all fine and great, but how do I know? How can I tell that by just looking at the equation? Well, you can't really just by looking at it. So what we're going to need to do here is solve it. So we're just going to follow our solving steps. And at the end, you'll know and you'll see that it's infinite, and I'll show you. Okay, so let's follow our solving steps. First step, simplify both sides of the equation. Okay, I look inside the parentheses here, 2x plus 4. Can't do that, they're not like terms. I have a negative sign in front of this parentheses, which is the same thing as having a negative 1 out in front, okay? All right, which means that's negative 1 times whatever's in the parentheses, so I'm going to do my distributive property. Negative 1 times 2x, that makes that a negative 2x. Negative 1 times positive 4 makes negative 4. Okay, now I don't multiply the negative 1 by the x over here because that wasn't inside the parentheses, so I just bring that positive x down. Okay, and I'm going to go ahead and bring down this other side, even though there's stuff I'm going to do on that side. Okay, so parentheses are gone over here. I still need to focus on, I'm not done with step 1 really. I need to simplify both sides still. This has nothing to do with the properties of equality. Just do what you can on each side. All right, combine like terms. I have negative 2x minus 4. I can't do that because of the fact that the 4 doesn't have an x on it. But I have another x over here. So I have two x's on the same side of the equal sign. Combine them. So negative 2x plus 1x. That is negative 1x, because negative 2 plus 1 is negative 1. So that makes a negative 1x, or negative x. Bring down the minus 4 equals, same thing over here. I have 3x minus 4x minus 4. The 3x and the negative 4x here can be combined. They are like terms. They both have x's. So what is 3x minus 4x? That is negative 1x. Okay. Bring down the negative, or minus 4. Okay. Now, second step in solving equations is to, if the variable exists on both sides of the equal sign, get rid of the smaller one. Well, it does exist on both sides. I have an x here and I have an x here. Okay, which one's smaller? Negative 1x or negative 1x? Well, they're the same, obviously. All right, but still just proceed the same. It doesn't matter which one you get rid of, they're the same. So how do I get rid of negative 1x? Well, to get rid of a negative 1, I would add 1. So I'm going to add x to both sides. Whatever to do to one side, I got to do to the other. That's 0, and this is also 0. So yes, by trying to get rid of one of them, they both go away. That's normal. It's okay. So bring down the negative 4 equals, and then bring down this negative 4 equals. Okay, now that the variables are gone, there's no more solving steps to do. Normally we would have to isolate the variable term, and then at the end isolate the variable. That's all done. You don't need, there's no steps to continue with because the variable's gone. All you have left here is a constant equals a constant. So you ask yourself, is this true? Does negative 4 equal negative 4? Yes, it does. So if you end up with the same, basically it's this. If you end up with the same number on both sides of the equal sign, then this is infinite solutions, or many solutions, okay? Meaning that it doesn't matter what number you put in for x back in the original equation. You could put in 13, you could put in 1,000,000, you could put in -5, any number you want, even a decimal. All right, as long as you put it in for all those x's, the same number, you are going to get negative 4 equals a negative 4 at the end of every single try you used, okay? So that's why every number would work. Every single number in the real number system would work as a solution. So that's what infinite solutions look like. You get to the end of the problem, the x is gone, and you get the same number on both sides of the equal sign. Leaving, of course, no solution. How do you know when you get no solution? Okay. All right, same thing. We're going to do our solving steps, and at the end, we're going to see how do we tell what no solution is, or what does it mean to get no solution. Okay, solving steps. Follow your PEMDAS, follow simplifying, right? Simplify both sides of the equal sign. All right, so I look at this here on the left-hand side. Can I do x plus 2 inside the parentheses? Nope, can't do that, but I can do the distributive property here. All right, 7 times x is 7x. 7 times positive 2 is positive 14. All right, I don't multiply the 7 by the negative 3 because the negative 3x wasn't inside the parentheses, so I just bring down the negative 3x. Now I have the same thing over here. Can I do 6x plus 3? Nope, because they're not like terms. The 3 doesn't have an x on it. But I can do the distributive property here. 2/3 times 6x, all right? 2/3, excuse me. 2/3 times 6 is 4, all right? 2/3 of 6 is 4, 4x, all right? And then if I multiply the 2/3 times 3, 2/3 of 3 is 2. 2/3 times 3 is 2, all right? So I end up with 4x plus 2 on the right-hand side of the equal sign. Okay, now keep following here. I am actually still not done with step 1. I can further simplify this side, right? Just simplify. That means that we've done the distributive property. Now we can combine like terms. I have a 7x and a negative 3x. Those are both x's. They can just be combined. So what is 7x minus 3x? 4x, right? 7x minus 3x is 4x. Can't do anything with a 14 because it doesn't have an x on it, so we bring the 14 down. This side is fully simplified. You can't do 4x plus 2 because the 2 doesn't have an x on it. Okay. So now I'm to really my second step in solving, which is if the variable exists on both sides, then I need to eliminate the smaller one. Well, we're right back to that like we were in the last problem. Yep, I got x on both sides. Okay, I need to get rid of the smaller one. Which one's smaller? 4x or 4x? Oh, they're both the same, right? They're 4x and 4x. So just proceed as you did before. Obviously, it doesn't matter which one you get rid of. We're going to get rid of one of them, and that's going to end up getting rid of the other one. So if I have a positive 4x, I'm going to subtract 4x from both sides, and they both go to 0. And the x is now gone, right? The variable has disappeared. So bring down what you have left. 14 equals 2. And the obvious fundamental difference here between the last problem and this problem is, in the last problem, you had negative 4 equals negative 4, and that is true. Does 14 equal 2? No, that's not true. 14 does not equal 2. So you're going to, basically what's going to happen here is when you get, when the variable disappears and you get to the very end and you get one number on one side of the equal sign and it's a different number on the other side of the equal sign, that is no solution. Because it doesn't matter what number you try to put in for x here, whether it's a negative, a positive, the number 0, a decimal, a fraction, it doesn't matter. No matter what number you put in x for x in this whole equation, no number would work. It would always come out as having the wrong number on the left, and it would not match the number on the right. Okay? So the difference between infinite and no solutions is the fact that the numbers will match at the end for infinite, and the numbers will not match at the end for no solution. And then, of course, one solution is you get your one number, your one solution for x equals that number and that number alone. Okay? So that's the difference between the end result of one solution, infinite solutions, and no solution. Good luck.